came together and we wanted to make sure that we had a solid foundation moving forwards with our design. So we came to the understanding that the problem definition, functions, and objectives constraints were very important for us to deeply grasp, especially the scope of the project. Essentially, we determined that our goal was to create a visually appealing truck that was electric to maintain low carbon emissions that can carry the most weight up a slippery puckboard.
We began by doing research on various aspects relevant to our design, such as tire width, gear ratios, weight distribution, and traction performance. We used credible sources and literature reviews to gather insights and understand the key factors influencing our design objectives. We carefully considered the feedback provided and iterated on our design to address any areas for improvement.
Once we had our selection of alternative designs, we went ahead and made our pairwise comparison charts as well as the weighted decision matrices. And we found out that the dip-down frame had a total of 66%, so we went ahead with that design. We created our final drawings of the assembly with all of the dimensions, and we calculated the torque and output of the vehicle, as well as the velocity. We figured out the costs of building and carbon emissions, making sure that we stayed within our constraints. And we found out that we only had 3.34 kilograms of CO2 emissions and $20 left in the budget, making us one of the most carbon and cost-efficient teams out there. Then we got to the fun part. We got to the building. We all spent a total of 3 to 4 sessions at the Hardy Lab working hard and coming up with our final model.
We evaluated our car by assessing its ability to ascend the ramp with and without weight added, ensuring the stability, durability under load, and the consistency of our car. We measured the performance of our car based on the speed, time, and weight capacity. Through this testing, we ended up adding elastic bands to the 2 rear tires and 1 elastic to the front to ensure that the wheels have proper traction so that our design meets the results we hope to achieve.